This video is going to cover opportunity and annuity. So first of all, what's opportunity? Opportunity is a string of level cash flow payments that never ends. So for example, if you purchase a stock and it agrees to pay you a dividend, say in the end of every year, and the dividend is a constant amount of money, say $10 per share, and it promises to pay forever, then this can be viewed as a perpetuity, which means you are going to receive these cash payments forever. Okay, an annuity is a level stream of cash flows at regular intervals with a finite maturity. So, for example, if you purchase a bond and it agrees to pay you a coupon, so in the end of every 6 months or in the end of a year, it agrees to pay you a certain amount of coupon, say $60 for each bond, then it will mature in say 10 years because it's a 10-year bond. Then this is a finite maturity date, which means this is an annuity. You are going to receive these cash payments within 10 years. Okay, but the payments will end after 10 years. Okay. So another example can be you heard about Social Security. So when you retire, you can get this amount of money from the government, and it's called Social Security. And the Social Security is you can get a certain amount of money every month until your death. So if you if you can live forever, then it's going to be a perpetuity. It's never end because you can live forever. However, in most cases, we know we are likely to die in maybe 30 or 40 or 50 years after retirement. So we may have a life expectation. But then, when we calculate the value of this future Social Security payment, it's we need to calculate it as an annuity. So we expect the payment will end in say 40 years because we are likely to be dead by then. So these are just the two models of future cash flows, and we are going to look into more details onto them. Okay. So first, how do we calculate the value of opportunity? There is a very nice and a simple formula. So first, by definition, the opportunity says you are going to receive a payment in each time period, and this payment will go forever. Suppose this payment is C, which stands for cash. So you are going to receive the cash payment C in the end of each time period, and the payment will go on and on forever. So for each payment, we want to discount it back to present value. So for payment in t equals 1, it's discounted once, so it's divided by 1 plus r. For the payment in t equals 2, we need to discount it by 2 time periods, so you divided c by 1 plus r squared, on and so on. You're adding everything together, and it goes to infinity because the payment never ends. And that gives you the present value of this opportunity. So you can see this is actually a geometric series, and then doing some simple math and apply the formula for the geometric series, you can see the present value of this perpetuity is actually C divided by R, where C is the cash payment you receive in each period, and R is interest rate. Okay. So let's look into one example. For example, in order to create an endowment which pays $100,000 per year forever, and how much money must be set aside today in the interest rate of 10%. Okay, so this is just asking you what's the present value, just perpetuity. So the cash payment is $100,000, interest rate is 10%. So apply the earlier formula, we have 100,000 divided by 10%, or 0.1. So we get it's 1 million. Okay. And there can be a twist to this question. So so in the last question, we see the perpetuity starts in the end of the first year. It starts now, in the end of the first year. However, if the first annuity payment is not received until 3 years from today, how much money needs to be set aside today? Okay, so this means we are going to receive the payment in a later time period. So it needs to be discounted back to today. Okay, so instead of divided by 0.1 to get the present value, so this is the present value in 3 years, then we need to go back to today again. So we need to further discount it by 1 plus 0.1 to the third. Okay, and that gives you the present value of 751 and $3,315. Okay. So next, let's look into the annuity. Okay. So for annuity, it says it's a payment that will have a maturity date. Say we receive the cash payment in each time period. Okay, and for T payments. So it starts with cash payment in year 1. And so this cash is divided by 1 plus R to discount it back to the present value. And then in T equals 2, we need to discount it by time T equals 2 here, and then discount it back to present value all the way go to the time T, where C is divided by 1 plus R to the T. Okay, so to get a formula for the annuity, we can think it as 2 parts. So first is, what if this payment never ends? Then it's just going to be a simple annuity. And we know the formula for the annuity is C divided by R. Okay? However, actually, after time T, we are no longer going to receive any payments. So we need to subtract this value, all the values after T to the present value. We need to subtract the cash we receive afterwards because the annuity already ends in time T. So that gives the second part of the formula. So it's still C divided by R, which is the value of the annuity. Then you are discounted back to today's value. So the formula for the annuity has 2 parts. The first part is C divided by R here, which is the value of the annuity. And the second part is C divided by R and divided by 1 plus R to the t. So that represents the value you are not going to receive after time t. Okay. So this is just explanation for this formula, but in the cheat sheet, you can just put down this formula. Okay. So C stands for cash payments as before, interest rate is R, and the T is the number of years the cash payments will be received. And this is the formula for the annuity. Let's look into an example. So suppose you are purchasing a car and you are scheduled to make 3 annual installments of $8,000 every year, and given an interest rate of 10%, what's the price you are going to pay for the car? Okay, so it's asking for the present value of these 3 payments in the future. Okay, so I will show you 2 ways to do it. So first is the very basic and straightforward way to do it, which is to think it as a future cash flow and discount everything back to today's value. Okay, so let's look into this graph. So in this timeline, in end of year 1, we are going to pay $8,000. In end of year 2, we are going to pay another $8,000, and in end of year 3 is going to be another $8,000. And we want to discount everything here, every cash flow here, back to today's value. So we have 8,000 in t equals 1 divided by 1.1. We have 8,000 in t equals 2, so 8,000 divided by 1.1 squared, and 8,000 in year 3, which is 8,000 divided by 1.1 to the third. And then adding things together, we get a total value of $19,894, and that's the present value of this future cash flow. Okay, so this is the easy and straightforward way to do it. So just like discounting the future cash flow. And then there's another way. So we think this as an annuity. Okay, we are paying a payment of 8,000 for 3 times. So t equals 3 here. we have 3 payments. Each payment is 8,000. So C is 8,000 and T equals 3. Interest rate is 10%. So R is 10% or 0.1. And we just apply the formula. Okay, just apply the earlier formula I gave you for the annuity, and we get 8,000 times 1 divided by 0.1 minus 1 divided by 0.1 times 1.1 to the third. And then you are supposed to get the same answer. You can try it by yourself. Okay, so this question is kind of simple because it only has 3 payments here. But in most cases, think about if you have a mortgage. Mortgage is also an annuity. Say you have a 30-year mortgage, you are making a payment every month. That will be 316 months payments. So in that case, it's very hard to do the math by yourself, to do it by hand. So we need to use a financial calculator. Okay. So let's look into the financial calculator first. So what you will see here is there are 5 things you need to know for each present value, future value, and payment. Okay. So the first thing is the number of periods. The second is I, which is interest rate. And the next is present value, PV. And the next is payment, PMT, which stands for the amount of money each payment is. And FV is future value. Okay, so if you know at least 4 things, you can calculate the 5th one. So let's use the last example. Suppose you are purchasing a car and you are making 3 annual payments. So M equals 3, I, the interest rate is 10%, and you want to know the PV, okay? And you know the payment is 8,000 already, and the future value is 0 because all the payments are made, so there is nothing left in the end of year 3. Okay, so future value is 0 here in this case. So what you will do is you input M equals 3, I equals 0.1, I equals 10. Okay, in the financial calculator, interest rate is just a number. So if the interest rate is 10%, you put 10, don't put 0.1, put 10. Okay, and the payment, you think it as you are paying the money. Okay, so you are paying $8,000. So you put negative 8,000, and they put a future value of 0. And then you press calculator, you press PV, and then you will get the same number as before, the 90,894. That's the present value of this future payment. Okay, let's look into another example. If you are taking out a mortgage for $100,000, you will pay it back in 30 years and paying 1% interest rate every month. What's your monthly payment? Okay, so this kind of question is hard because you cannot do it with your hand. However, it's easy if you just use the financial calculator. So you are paying 30 years and pay it every month, so it's a total of 360 payments. Okay, the interest rate is 1%, so you just input I equals 1 here. And the present value, okay, the PV here is you take the size of the mortgage, and the mortgage is $100,000 here. So PV equals 100,000, and the payment is what you need to figure out. And the future value is again 0 because in the end of the payment you don't have any future value. Everything, the payment, the value of the payment discounted back today should be equal to the present value. So the future value is 0. So you input M equals 360, I equals 1, PV equals 100,000, and the future value equals 0. Then you press calculator and you press the payment. You will get a payment of negative $1,028. Okay, so what is negative sign here? So actually you can ignore it, but the reason there is payment is negative because PV is saying positive here, which means if you are receiving a positive present value, it's the money you receive for the mortgage. So in the future, you need to pay the mortgage, so you're paying out. So if you have a positive present value, is you're receiving the mortgage, receiving the money, you are going to pay in the future, and that goes to the opposite side, which gives you a negative. So if you choose to have a negative PV, say if you input negative $100,000 instead of $100,000, then you will get a positive payment. Okay, so this is just those two things are just like you think as you are receiving money or you are paying out of money. Okay, so I will post a YouTube link for tutorial on the financial calculator. It will also teach you how to like change the decimal places of your calculator, so you can look into that videos to learn more about the financial calculator. Okay. So last part, I will also mention something called annuity due. So for an annuity and for opportunity, we usually assume we receive the first payment in the end of the first time period. Okay, so in the end of year one. However, annuity due is a similar idea to annuity, except that the level stream of cash flow it starts immediately. So instead of receiving the money until the end of the year, you are receiving the money right now, okay, immediately. So the present value of annuity due, you are receiving the money one time period earlier. So when you calculate the present value, you just simply need to times the present value of the annuity times 1 plus R. Okay, so you just earning extra interest because you are receiving the money today instead of the end of the year. Okay. Similarly, for the future value of the annuity due, it's just the future value of annuity times 1 plus R. Okay, so for the annuity due, it's receiving the money right now instead of the end of the year. So you are earning the interest over this year, and that's the reason why you need to multiply it by 1 plus R. Okay, there's nothing fancy about it. So you need to keep in mind when you look into a question in exam or in homework, whether it's asking annuity due or it's annuity.